Okay. This was like muted there. Okay, so the what I said was that we must make a table when it comes to the table method, and then we have to choose our own x values, and the x values in this table is 0, 1, and 2, but we can also choose negative values or whatever values is suitable to the equation that we're working with. Okay, so in this case it's just a whole number, and what they've done here is they have given us y plus 2x equals 3. Okay, so I'm quickly going to create a new screen. So they said y plus 2x equals 3. So we have to make y the subject, because every time you have looked at an equation for a straight line graph, it said y equals, isn't it?
Yes.
Okay, so how would we be able to make y the subject in this equation? That means isolate y, doesn't it? Yeah. So how can we isolate y therefore? Make y alone on the one side. Are we just going to say minus 2? Minus 2x if we want to take away that whole term. Okay, we want to take away the whole term of positive 2x, so we say subtract 2x, and we do the same on the right hand side. But are these two on the right hand side like terms?
No.
No, so we cannot say 3 minus 2x. We rather just express it as a expression which contains an x term and a constant term, just to remind you of that vocabulary. So then y is isolated because 2x minus 2x on the left hand side is 0. And then it's equal to, and what do we write first out of 3 and negative 2x?
Negative 2x.
Good. Negative 2x and then plus 3. It was positive 3. Why? Because do you remember we said that the standard form of the equation is y is equal to ax plus q? Remember that? Okay, so we follow on what they told us the standard form was. Okay, right. So you have to be able to do this as well. Put it in the standard form. In other words, make y the subject or isolate y. Okay, so do you want another one to try and isolate?
Yes, ma'am.
To try on your own quickly, in pencil in your book, it doesn't matter. Okay, so let's say I have okay, are we good? So what would be your first inverse step?
2 negative 2 minus 3x.
Subtract the 3x both sides, make it that side 0 then.
Yeah.
Y is alone, and then on the right hand side we should have negative 3x
Plus 5.
plus negative 5, which becomes minus 5. Yes. Okay, good. There we go. That's it. That's all there is to that. Okay.
Yes.
Okay, so that part is easy in case. And it just makes it easier to do your calculations because then y is already isolated. Then you've got y equals answer. You just substitute on the right-hand side. Okay, so that's the whole idea of why we did that. So like I said, and you can start writing this down. I'll zoom in on that just now. Make up a table with at least 3x values. Then find the y values by substituting in the x values into the equations. Okay, can you see that there? It was bigger just now, wasn't it?
That's fine.
I don't know what I did. But I'm checking if I think I sent this document to you guys as well on Friday. So you do have it if you want to refer to it. Okay. Okay, and after you found those three sets of coordinates, the x and y values, you plot the points, join the points, and you draw a straight line graph, in other words. Okay, using those. After that, you can copy the table. This just says x and that y, and then there's our selected x values that we're going to independently choose and put into our x, substitute into x in the equation every time. Okay.
Yes.
Yes, please.
You must go to the table now.
Say example, sketch y plus 2x equals 3, and then that's the correct form, y equals negative 2x plus 3.
So we just make our own experiment.
Yeah, no, but we're going to do this as an example, so we need to have the same x values, but usually you just choose your own x values. Okay. So what's happening basically is as x changes, we want to see what happens to y, because for every function, it's a different reaction to what happens to the y values. And that affects how the graph rises or falls.
Now to write all the green things now.
No, you don't need to, but you can rewrite, because that's basically what we practiced just now on the other page. Rewrite the equation in standard form to make your calculations easier. That's what we did on the other page.
So now we just stops at 2 is the 3, 4, 5.
0, 1, 2. We just needed these three x values. And this is what makes this method a bit more accurate than what we did for the x and y intercept. For the x and y intercept method, you can't see when it is out. Okay, because obviously if you just connect 2 points, it's going to be a straight line. Okay, but if it's three points that we're going to join, you can easily see when something has gone wrong. Because then if you have to connect 2 and then the other one, and it goes like this, then you can see it's not a straight line. Then you know if something's not right, go back to my calculations and see where I've gone wrong. Okay, yes.
Does it end at 2?
Does it?
End at 2.
Yes, we're only going to work with 3 values now, but you're more than welcome to choose more x values. But at
But
least
in the test, will it ever count marks, how many you do?
no. And remember, you guys are writing a fill in. No,
But it's
Oh, so we're not even folio paper.
no folio paper.
Yay!
oh, that's so nice.
Okay, so 28th and 29th of September.
So for third term now, will we have like a big test? No, is it just going to be tiny test?
Yeah, well, third term is just tiny tests.
Fourth term, we'll
Fourth
have
term, there's going to be a big test.
of geometry one time.
I don't think it's just going to be geometry. Okay,
We're still gonna do geometry.
I'm still going to revise it, yeah.
I mean, this is geometry, man.
This is not, this is algebra.
What?
Okay, can we start filling this in?
Yes.
Okay, so guys, we have to do the calculations for this, of course, and all you do is substitute into x in the equation that we just isolated y. So if I go ahead then and say, let's just choose a colored pen that stands out here. So if I say for this x value, y equals, and then we say -2, and then in brackets 0, and then plus 3. Then I put it into my calculator and I get the corresponding y value, and that is 3, right? And then you can fill it in on the table, okay? But you can also, you don't have to write this down always, okay? Onto your paper or whatever you are working on. You can literally, it helps now so you can see what you've done, but you can literally put it into your calculator, -2 brackets, and put in the brackets whatever the x value is plus 3. Then, if you want to go work or calculate your next x value, you just press this button. Let me just grab my calculator for you guys and show you what I mean. So I'm putting in the -2 brackets. I'm just keeping the brackets empty for now, plus 3. Then every time you just go left, you put in the value, say, equals. Then you go left again, and you delete what's in there. You now say 1, and you say equal. Then you get your answer, put it in the table, then just go left into the calculation, and you just change that value in the brackets every time. It's the same method. What's wrong with it?
It's a sharp, not a castle.
Yeah, but it's supposed to do the same thing. -2, no, not 0, -2. I don't know. Mode, normal. But why does it have to say normal? Yes. Equal. Oh, no. I don't know how to fix that. Yes. Oh, enter. Where's enter? I don't know. Okay, so and then we're just writing down calculations here in this example, as I mentioned, for you to refer back to as to what we've done. So here we go, y equals -2 times 1 plus 3, and that gives you 1. Y equals 1, and then we go and fill it on the table. Then when x is 2, we say y equals, let me just do this, equals -2 times 2, let me just move that, plus 3, and -2 times 2 is -4, and -4 plus 3 is -1, and then we put that in the table. Okay, and then we have completed our table, and if you have to do it like this, you're going to get marks for the table, for completing the table as well, for getting the right corresponding y values. Okay. Then they just tell you if your ruler does not pass through all 3 points when you plot them, then it means something has gone wrong with your calculations. Go back, fix it, and then move along to plotting the points.
Okay, now we're going to do the graph.
Okay, so now that's all there is to this. We have to just draw the graph. And I forgot to put what am I doing here? Delete, undo, undo. What is this? I'm just playing around now, and it's on the recording. What's going on? I don't know how to stop it. Okay. How do I undo that? Oh, shut. It's always on the recording that things like this go wrong.
Then I can hear you clearly.
That's okay. I'm going to go to the next page. Okay. So we have to plot those points. Let me just get a Cartesian plane on here.
Technology.
Okay. Now we have to plot the points, Ned.
Must we draw the...
So quickly draw a Cartesian plane. But as you can see, I've done 6 all the way around.
How
Ned.
many do we need?
So what I've done with the other class on Friday was, I think the maximum value here was 3, isn't it?
Yes.
Is it even?
Yes.
So, yeah, so 3 all around at least. That's what you need. Okay, so 3 up, 3 down. That's 6 lines altogether. 3 left, 3 right. That's 6 centimeters altogether.
Okay.
We weren't done.
When do you think to put our classwork books online and workspace in the computer instead of writing down?
I don't know. I don't think that far.
Then all one has to do is log into your account and mark your book whenever.
I would like you to do that, but not everyone knows how to do it. You can do it on OneNote. You know, I don't know if I showed your class that.
No, you did not.
Same thing, where you can literally just do it on notebook, on this, for example. Okay, can we move on?
Yes, ma'am.
Yes. No, okay.
Continuation.
Then we got the point. So what is the when we value of 0? 3. That is indeed actually our y-intercept, is it not?
Yes, ma'am.
Because the x value is 0. So we plot the point at 0, 3 on the y-axis. Then the next point was 1, 1, isn't it?
Yes, ma'am.
1 for x, 1 for y. So we plot a point at 1, x, y, 1. Okay, x, 1, y, 1. And then the next value was 2, negative 1. So then we go 2 to the right, 1 down, and we plot a point. Okay. And then, of course, we draw a line through those 3 points. And that's how easy it is. Okay. I'm just looking for my ruler quickly so I can also draw a straight
No,
line.
you know how many people last year in my class failed because of this thing?
No,
I
no.
have a question.
You're lying.
Is the school a semi-private or is the school on public?
Say again.
Is the school semi-private?
It's not private at all. It's fully public.
It's fully public, not even a model C.
I don't know.
I've never seen a public school that has a swimming pool, man.
It's probably, but it's all Model C then. Yeah, I'm just trying to get the,
It
there we
works.
go.
Imagine. Wow.
Right, so there's an actual straight line
Fancy.
for a change. And then what do we have to do? Are we done?
No, we label the graph.
You can't leave it empty, no.
Mm.
We have to label the points as well as the name of the graph.
So first time.
So what's the name of the graph again? Y equals?
Negative 2x plus 3.
Y equals negative 2x plus 3. And then just put your arrows here to say the graph is continuous, because it doesn't stop there, does it? Okay, it continues. Okay, and then we label these points that we've plotted. So 0, 3, 1, 1, and 2, negative 1. And there's our fully completed graph.
And how many marks is this before?
3 marks, 3 marks. Okay. Yeah, somewhere at the end.
You have
Okay.
always said at the end of the line.
At the end of the line. Okay. And that's not difficult, is it?
And I
Right.
have the arrowheads
At the end of the line.
is it compulsory?
Yes, because it shows that it's continuous. Okay. You won't get penalized if they're not there. Okay, but it shows an important aspect of the line. Right, now back to this page. Oh, that thing is gone.
Yeah, oh, it's still spinning there.
No, it's not. It's because I'm doing it. Okay, now I want to show you this. F of x notation, that is your next heading. Let me just show you what I mean by saying f of x. So this is pronounced f of x. So that's your next heading. Okay, f of x notation.
Yes.
Is that on heading?
That's your heading. So we're going to look at f of x notation, which kind of relates to what we've just done for the table method, because all that it entails is that you substitute. So f of x notation, where we have got the f of x equals,
F of x, ma'am.
that-
There's no f in x.
this is pronounced f of x, okay? So if I've got this just being, sometimes we're going to have it expressed as f of x equals, let's make an equation of 2x plus 1. Okay, that's just, it means the same as y equals, let's just say e.g. f of x equals 2x plus 1 means the same as,
2x plus 1 equals f of x.
same as y equals 2x plus 1. Okay, and the only reason why we use this f of x, and sometimes it will be named g of x, but the general name of it is f of x.
Will you ever do it in an exam to confuse us?
Not to confuse you, it's actually to help you. Let me just speak. So the reason why we do this is that sometimes we can have more than one graph on the same set of axes, but the graph's equations are unknown. So the next time you guys are here, the lesson is going to be with regards to finding the equation from information given on a graph. Okay, by just looking at the information on the graph, we can actually find the equation. And then sometimes, therefore, the equation or the name of the graph is not given. Then we name it, and sometimes, like I said, there's more than one graph, and we have to be able to distinguish and work with their names. So then we just name it f of x, let's say, and g of x. Those are the popular ones. Okay, yes. I'm not muted. I'm muted on, yeah, the one that you see here, but on my tablet, I'm not muted.
Never can hear you though.
And I said, yeah. Yes. No. Okay. So f of x is f of x because remember, y is described in terms of x. That is why it is f of x. Okay, because the function in terms of x. The function of y in terms of x. Okay, so that was a very important question. Okay. Very, very important because it actually had me explain something that I wouldn't have thought of, that you don't know, that I know, that you wouldn't know. Okay, so please do ask questions when you have them, although it seems silly. Okay, right, so I want you to just copy that off the board. F of x. Let me just write it here as well. So f of x it's going to move now, equal to 2x plus 1. It's going to move now. It's just a bit slow. Means the same as.
Oh, there it is.
Y equals plus 1. Okay, it's coming. It's very slow.
But it's only on my phone, ma'am.
I know, it's just slow.
It has to go from there to there.
Probably.
to there.
Okay, so did you write that in your book? means, yeah. It's what exactly what's on the board there is what I'm writing here. It's just for the video so that people can see it. Okay. Okay, now, so like I said, sometimes we want to compare graphs and we need to have them on the same set of axes. Then we could name them with alphabet letters such as F in terms of X, G in terms of X, H in terms of X, okay? And then that is especially if their equations are unknown at that specific
This needs to be written down next.
stage. So you can summarize that. You don't have to. You can just say something like what I said. Sometimes there could be more than one graph on the same system of axes. Then we name them with different alphabet letters when their equations are unknown. Okay, something along those lines, or you can just copy what's on the board. And then you can start writing the method down as well. The method is basically that you substitute into the brackets the different X value that's in the brackets. Okay, we're going to look at it just now.
So ma'am, why did they choose F? I pulled it out. Why X? Why
I think they chose F because of the word function and you're working with function.
and G?
Then it just follows. So the function alphabet starts at F.
Okay.
No, I don't know. You can't have like that many graphs on. The most I've seen is 3 or 4. F, G, and H. We don't do R.
J.
We do this J, but I think after that, the one that we prefer is KFX. Seen that before. Okay, so then you can write down working with f of x notation. You take the method is you substitute the value given in the brackets instead of x, okay, into x on the right hand side of your equation. It's like a shorthand as well to express something, substitution. You don't have to do this in the table at all. Okay, this you can just write down. For example, if we've got y equal to x plus 2, then we have to tell you. So if x is 3, then y is what? Then you know that you substitute and you say then y is equal to 3 plus 2. Instead of the x value, we substituted with the x value they gave us. And that is then 3 plus 2 is 5. Okay. But now a different way in which they express this is if they say, well, f of x is equal to x plus 2. What is f of 3? Do you see that x is now replaced with 3? What they mean is just that now x is 3. And you just substitute this the same as you did with the previous explanation with 3. So it should be, what is the function in terms of when x is 3? So that also gives you 5, of course. So that f of whatever just is a different way of saying y equals, but it's got so many functions because now I can just say, well, I can see that the function in terms of when x is 3 is this. So you can see what's x and you can see what is y. from there. It could pause. Okay.
I'm gonna do more of this.
Are we going to do?
More of this.
Oh, yeah.
Ma'am, can you take out these things on the side? You can't see the right.
I can't really take this off. But what I could do is do that.
Ma'am, you said you don't do the thing, right? You just practice it.
No, for now, we're just exploring what f of x notation is, okay, and how to work with it. Okay, then the next example says f of x is now the function negative x minus 3. What is f of 1? Then we just substitute that x value with 1 now. We get negative 1 minus 3. And what is negative 1 minus 3? So that is negative 4, the corresponding y value. Okay. Do you quickly want to try the next one on your own? F of x equals 2x. What is f of negative 6? Okay, what did you get for f of negative 6 there?
Negative 4.
2 times negative 6, and that is negative 12. Okay, continue with H and G. And then we're finished for this lesson.
Am I really flashing my watch here?
I know. I'm even taking one out here.
Yeah.
Okay, so for today, 3, 4, and 6 from activity 5.8. So for 3, it's just,
Now it's h of x, ma'am. What's going on?
it doesn't matter. It just, that's to show it can have a different alphabetic name. It's not always f of x. Okay, so number 3 is just complete the tables and then 4 draw the graphs for these tables. Okay, they give you the x values, you find the corresponding y values, then draw the graphs, and then 6 is another table, but they don't give you the equation in an equation, actually, they give it in words, in a description. So they say, given that the output is the sum of twice the input plus 3, you have to describe that or write that as an actual equation. What would it be? Given that the output, y is always your output, okay, is the sum of twice the input plus 3.
2x plus 3.
That's it. The sum of plus twice the input 2x, we know that comes first. Okay, 2 times x. And then, what is it that we're adding it to?
3.
Okay. So you just have to write that equation for yourself and then substitute all the x values they provided you with into that every time. Okay? And then list the ordered pairs as in write it as a coordinate. That's what it tells you. And lastly, plot a graph to represent that data. Okay, so it's literally just for 5 tables and 5 graphs that you have to do all in all. Okay, and then the homework for tomorrow, and you can do this today and tomorrow even, you don't have to do it all today. Revision activity 5, page 201. Number 5 and number 6. So number 5, once again, tables, and 6, draw the graphs. And you can start immediately, okay? You can do whichever one you want
So it's
first.
classwork and homework, that's it.
Yes, but if you want to also, once again, you can print out those Cartesian planes.
And DBE is compulsory.
No, it's optional. Okay. It's optional. It even says there, optional. Okay, now, okay. Can I do h of x and g of x? Yeah, that's what I want to do. So h of -1 in this function would be 3 times -1 minus 4. And then 3 times -1 is -3, and -3 minus 4 more is -7. So then g of x being x minus 1, then g of 2 would be 2 minus 1, and that is 1. Okay, so we can see what the coordinates are every time. Over here in this block, we have the coordinate 3, because that's what's in the brackets, and the y value that corresponds to that, 5. For this function, it's all different functions though, okay? So I actually don't want to write down the coordinates because I'm going to confuse you. Okay, but just to show you can see the x value and you can see the corresponding y value easily.
Now, for H, is it negative and the negative?
Okay, but see, 3 times -1 is -3. But if we add a negative and a negative, it means you are at -3 on the number line. You're going to move 4 more left. So it's a different story. When you're adding a negative and a negative, it is negative. It remains negative. It doesn't move right. So there's no chance of it becoming positive. Okay. But yeah, negative times a negative is positive. Are we good? And then this number 5, I'll do with you in class next time. Okay, that I scratched out. Must I display the homework on the board?
No, ma'am, we do it at home.
The questions.
Say homework.
Some people actually said it. What?
Actions.
You what?
I'm confused.
What's wrong?
Because ma'am, you said that you multiply, but 4 times -3 is 1.
I didn't
why?
say you multiply. I was just explaining a concept of when you multiply negative and a negative, it is positive. But here, it is 3 times -1, which is -3. And then we're adding -4 to it, which should be a negative answer.
So it's -7.
So I was just explaining the difference in the two concepts.
Mark says, okay.